Okay, my boys and girls and students and teachers and whoever else is watching this, we're on 2.3. Man, we're like halfway through the year, and it's only October, and it's going to take forever. Forever. That's like math class. All of this material can be found at www.nkinfinity.com. Now, at the bottom of this page, you'll see www.algebra2commoncore.com. We own that as well. That'll take us to NK Infinity, where you can find a nice organized list of all of these videos. I don't even know what I'm saying. By the way, N stands for Newman. She's my partner in crime. That's Miss Vicky Newman. K stands for Krause, or in this case, Mr. Key. All right, let's get started. Make a list of the perfect squares that you know quickly. Now, I'm going to list all the ones I think you should know. The list the perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and then everybody pretty much stops there like, 169, that's 14 squared. No, that's 13 squared. 14 squared is 196, and then 225. I really think you ought to know others. When I was teaching Algebra 1, I used to make my kids memorize up through 15. This is 15, by the way. 15 squared is 225. But I made my kids memorize 400, 900, 1600, 2500, 3600, 4900, 6400, 8100, and 10,000, or 100 100s. Notice it's just 100, 81, 64, 49, 36, 25, 16, and all the perfect squares, okay? So you should have a real good handle of what perfect squares are. You know, if I say, what's the square root of 37, you'd be like, dude, I don't even know. It's a little more than 6, but I have no idea. But if I say, what's the square root of 64, 8 should pop off your head. All right, so never leave a perfect square under a radical. That's stuff we're going to do in class. That's for fun. You guys hopefully did some kind of fun stuff. We're going to reduce all of these radicals. So your goal is to find the largest perfect square that goes into them, that divides evenly in them. And, you know, generally these are pretty easy. You know, this is the square root of, this is how I reduce. I don't know how your teachers taught it. I do 4 times 2, and then I grab a different color, and I go, okay, the square root of 4 is 2. So this is 2 square root of 2. And then I say, okay, this is the square root of 4 times 3. And the square root of 4 is 2 again, and that becomes 2 square root of 3. And this is 4 times 5. Square root of 4 is 2, so this becomes 2 square roots of 5. This is 4 times 6. Square root of 4 is 2, so this is 2 square roots of 6. You guys getting the picture? All right, one more. 4 times 7, so 2 square roots of 7. All right, so, and then this one is the square root of 9 times 2. The square root of 9 is 3. This becomes 3 square roots of 2. This is the square root of 9 times 3. 9 is 3, so this is 3 square roots of 3. Square root of 9 times 5. Now, I didn't do 9 times 4 because that's 36, and that's a perfect square. We didn't want to use that one. Square root of 9 is 3, so that's 3 square roots of 5. And this is the square root of 9 times 7. Square root of 9 is 3. 3 square roots of 7. These should not be anything that you can't do. In fact, in my class, I'm just going to have my kids just go to town on these and spend a whole lot of time. So I'm going to pause the video right now. Well, no, let's just keep going through them. This is the square root of 16 times 2. That's 4. 4 square roots of 2. Square root of 16 times 3. This is, by the way, is one of our favorites. We love that one, 16 times 3. Because how many of y'all actually know you'd probably do 4 and 12 or something like that, but it doesn't work. Square root of 16 is 4, so 4 square root of 3. Tired of this pen. Let's go with purple. 27 I already did. I don't know why it's on there again. This is the square root of 16 times 5. Square root of 16 is 4, so 4 square roots of 5. This is another one we love to ask. Another one we love to ask. Square root of 96. This doesn't happen very often. It's 16 times 6. The square root of 16 is 4, so this is 4 square roots of 6. And then this would be 16 times 7. Square root of 16 is 4, so 4 square roots of 7. Now the next groups are really easy. They end in a 5. If they end in a 5, there's like a really good chance 25 goes into it. Square root of 25 times 2. Oh, 5 square roots of 2. The square root of 25 times 3. Oh, 5 square roots of 3. I didn't use 100 because 100 is a perfect square, so it's 25 times 5. Square root of 25 is 5, so it becomes 5 square roots of 5. And so anyway, basically if it ends in a 5, 25 probably goes into it. Now I'm going to tell you right now, this is the single most asked perfect square ever. And the reason it is because everybody wants to pick 9 and 8. 9 is a perfect square, but 8 has a perfect square in it too, and it's 4. So don't pick 9 and 8. By the way, if you do pick 9 and 8, and you go, wait a second, 8's got a perfect square, I could do it like this. 9 times 4 times 2, square root of 9 is 3, the square root of 4 is 2, so that makes 6. So 6 square roots of 2. But I hope that at the trig level and at this algebra 2 level, that you guys start to recognize, oh yeah, that's just 36 times 2. Know that we're going to ask that one. Square root of 36 is 6, so I get 6 square roots of 2. This is 36 times 3. Square root of 36 is 6, so this is 6 square roots of 3. This one's asked a lot too. This is the square root of 36 times 5. Again, I can't do times 4 because that's 144, and that's a perfect square. Square root of 36 is 6, so 6 square roots of 5. And finally, the weird one, 49. This is the square root of 49 times 2. Square root of 49 is 7, square roots of 2. This is the square root of 49 times 3, 7 square roots of 3. And this is the square root of 49 times 5, 7 square roots of 5. All right, let's get going. Oh, I should probably pause this. I'll be back. Okay, so these are a little bit more tricky, but not much, not much. So what we're going to deal with these is, we're not going to mess with the 6. We're going to leave that where it is, 6 times, and we're going to simplify the square root of 12, and that's 4 times 3. I come in with my other pen. I say, okay, the square root of 4 is 2. So this gives me 12 square root of 3. All of this should be reviewed right straight from algebra. I'm going to do 3 times the square root of 100 times 2. Of course, if it ends in double zeros, 100 goes into it. The square root of 100 is 10. This makes 30 square roots of 3. So I think I meant to have this go over here. But anyway, the square root of x squared. Oh, we haven't talked about that yet. All of a sudden I had a brain cramp. I thought I taught you rational exponents. I have not taught you rational exponents yet. Okay. So what you need to remember is the square root of x squared is really just x. Well, let's think about it this way. Let's think about it this way. Let me slide over here and get some work done. Oh, why do you do that all the time? That was yesterday's assignment. Okay. So the square root of 9, can't that be written as, well, isn't this equal to 3? But can't I rewrite this as 3 squared? Like, isn't 3 squared the same as 9? So it's equal to just 3. The square and the square root, they just cancel each other out. The square root of 4 squared. Well, that's really 16, isn't it? And isn't that the square root of that just 4? The square and the square root cancel each other out. Let me do one more. Square root of 6 squared. Again, this is just, that's really 36, which is just a 6. So the square and the square root cancel each other out. So when I'm working with variables, I have to remember that. Oh yeah, this square and this cancel each other out. Now this is not a perfect square. So what we're going to do is we're going to rewrite it as y squared and times y. I want to rewrite it as something that is a perfect square and something that is not a perfect square. Well, what is the square root of y squared? This square and the square root cancel each other out. It just gives me y. So this becomes y square roots of y. So when we're talking about square roots, we're looking for groups of 2. So this, normally I won't do this, but I'll show you. This is really z squared times z squared. Well, what's the square root of z squared? Oh, that's just z. What's the square root of z squared? Oh, that's just z. So what do I have here is z times z, which is z squared. So for every 2 variables, squared, fourth, sixth, 8, I can take out 1 variable. So what I'm trying to say here is because this is even, and this is 2 groups of 2, z to the 4th is z squared. Now n to the 5th, I'm going to rewrite this as a perfect square and not a perfect square. So when you want a perfect square, it is a perfect square has an exponent that is even, or a multiple of 2. Same thing, right? Even or multiple of 2. So I just want to write this as an even exponent and then a 1. It'll always be that for square root. So n to the 4th times n. That makes n to the 5th. And I say, okay, I know that the square root of n to the 4th, there's 2 groups of 2 there. That's n squared. So this just becomes n squared square roots of n. Now this already is even. So how many groups of 2 are there in 10? 2, 4, 6, 8, 10. There's 5 groups. So this is equal to m to the 5th. Hope you're catching on. Eventually you will. Let's keep moving on. All right, so now we're going to just get all freaky diggy on us here. Okay, so we're going to get this. Now, first we're going to deal with the 100, or the 200. That's 100 times 2. X cubed is not even, so we're going to make it even. And what's left over? Y to the 6th is even, so I'm going to leave it. And z, I can't do anything with z. It's just z. All right, now that I've written it all as perfect squares and not perfect squares, I'm going to come back through. Square root of 100, 10. The square root of x squared, x. There was only 1 group of 2. This one has 3 groups of 2, so this becomes y cubed. I can't do anything with this x, I can't do anything with this 2, and I can't do anything with this z. So my answer is 10x y cubed square roots of 2xz. Done. All right, now let's go. 56. 4 goes into 56, right? How many times does 4 go into 56? 56 divided by 4. 14 times. Is there any perfect square that goes into 14? I didn't think so. So we're going to rewrite this simply as 4 times 14. M to the 4th is even, so we'll just leave it. But n to the 7th is not. So we want it right to the closest even number to 7 as we can get. So we're going to write it as n to the 6 times n, because that makes 7 n's. And as long as it's even, we're okay. Square root of this is 2. Now, how many groups of 2 are in here? 2. So this is m squared. How many groups of 2 here? 3. N cubed. So wait a second here. I got this 3. Don't just put a 2 there. That's 6. Remember, it's multiplication. m squared n cubed, square roots of 14n. 243. Let's leave this d out here. Let's see. Well, if you're working with your calculator, eventually you'll figure out that 9 goes in. Let's see how many times 9 goes in. By the way, 9's not the biggest one, but let's just see how many times 9 goes in. 243 divided by 9. 27. Is there a perfect square that goes into 27? Of course there is. 9. So the largest number that actually goes into this is 81. It's 81 times 3. Sometimes it's hard to find the biggest one first. A squared is already even. We'll leave it a squared. B to the 4th is already even. We'll leave it b to the 4th. C to the 12th, already even. We'll leave it c to the 12th. As long as it's even, we're okay for square roots, not for cube roots. We'll talk about those later. So let's get going. Square root of 81, 9. Square root of a squared, a. The square root of b to the 4th, b squared. 2 b's, 2 sets of 2. And this one has 6 groups of t. So this is, c. So this is 6 groups of 2. So this is c to the 6. C to the 6 is hard to say. All right. So now we're going to multiply. We get 18. That's the 2 times the 9. A, b squared, c to the 6, d. Don't forget the d. Square roots of 3. Wow. Exciting stuff. All righty, let's see what we got left here. Come on. Another thing, rule, we call them rules. The second rule of square roots, they're not official rules, but the second rule of square roots is you should really never leave a fraction under a radical, or you should never leave a radical in the denominator. Never leave a radical in the denominator. So we want to look at simplifying this. We should not have this, but you do need to understand that this is a legal move. It's fine. You can do that. Go ahead. You can do that. Might as well. All right, so what we're going to do here is, whoa, what the heck just happened? This one can't be simplified, but we can rewrite this as the square root of 242x to the 5th all over the square root of 25y to the 4th. Ooh, my air conditioning is coming on. Yay. All right. If you're watching this in the middle of winter, not so good, but it's 95 degrees out today. All right, let's deal with this first one. 242. What could possibly... What, 16? I don't know. I'm going to try even numbers. Let's try 36 first. 242 divided by 36. No, 242 divided by 64. No, 242 divided by 16. $242, what? Oh! Divided by 2. 121. 121's on our list. So 121 times 2. Now x to the 5th is odd, so we're going to write it as an even and just a plain old 1. And that's a perfect square. That's all perfect squares. I can just deal with that one right there. That's 5y squared. All right, let's take care of the numerator. This is 11, and this is x squared. So I get 11x squared, square roots of 2x, all over 5y squared. Done. All right. Now this one, we're going to simplify first. This is another method to do this. Because 16 actually goes into 64 4 times, and I can get rid of one of these a's, that leaves me 11 a's up here. So what I'm really left with is 4a to the 11th. Again, you know, if I wanted to blow this up, so you can see it, this 16 divides evenly into 64 4 times, and one of these a's canceled with one of these a's, and it leaves me at 11. So that's why I have 4a to the 11th. 11 is an odd exponent, so I don't want to keep that. So I'm going to write it as 4a to the 10th a. Well, okay. What's the square root of 4? 2. What's the square root of a to the 10th? That's 5 groups of 2, so a to the 5th. So my answer is 2 a to the 5th square roots of a, because the only thing I couldn't deal with is that. All right, so this one's a little bit different. So we're going to write it as 5. Now let's see. This m cancels with one of these m's, leaves me 4. And this n cancels with one of these, it leaves me 6. So I'm going to rewrite this as the square root of 7k all over the square root of 225 m to the 4th n to the 6th. You're going to want to simplify before you break it up. All right, well, I can't, I'm just going to leave the numerator. I'm going to leave this in the numerator. 5 square roots of 7k. Can't do anything with that right now. Oh, and this should be 225. Sorry about that. Wow, that's a big eraser. So, all right, let's go through. The square root of 225 is 15. The square root of m's 4th is m squared. And the square root of n to the 6th is n cubed. Not quite done yet. This 5 goes into 15 3 times. So my actual final answer is the square root of 7k over 3m squared n cubed. All right, kids. Just found a major mistake in my calculator. All right, so the third rule is we never want to leave a negative under the radical. So this is a problem. So normally I would say, well, we can't really do anything with that because we have a negative. I could just say, oh, okay, wait a second. The square root of 25 is 5, and the square root of x squared is x. So my answer is 5x square roots of negative 1. Because there's still a negative there, so it'll be negative 1. But, surprise, surprise, go to the next page. We are now going to introduce you to imaginary numbers. You know, because math wasn't hard enough. We're going to introduce numbers that really don't exist because they're imaginary. So, me, my little friend, I. Yes. We have the imaginary number I. Now, don't draw all this. You know, that's kind of weird. Looks like a 1. Make sure when you draw your I, it looks like a nice curvy little I, so you know it's not a variable. It is equal to, by definition, the square root of negative 1. Now, because I now have something to deal with, now I have some way of dealing with negatives, I can rewrite this. So, the square root of a negative, and there's really a negative 1 here, is I. So the square root of negative 25 is 5i. Oh, so because that's negative, it's 5i. And the square root of this is x. So my answer is 5i x. Sorry. Got a correction on that one too. Okay, so, all right, we're ready to go. Let's go. Now, wait a second. 17 is not a perfect square, so then as soon as you see a negative underneath, you know, hey, I'm going to have I in my answer. So there you go. That's I. And the square root of x squared is just x. So ix square root of 17. Boom, shakalaka. 10. Now we're going to rewrite this. The square root of, now 49 goes into 98. So I'm going to write this as negative 49. You'll see why in a minute, times 2. A squared b. What am I doing? A squared. I need to make up a cubed, right? So a squared a, that's 8th cubed, times b to the 8th. All right. The square root of negative 49 is 7i. The square root of a squared is a, and the square root of b to the 8th is b to the 4th. So nothing new except for that I. So this is 70i a b to the 4th square roots of 2a. So this is really equal to the square root of negative 3y to the 4th over 64. Square root of 64. So the square root of I, negative, is I. The square root of y to the 4th is y squared. And the square root of 64 is 8. So you end up with I, y squared, square roots of 3, all over 8. 243, we just dealt with that. Do you remember what number goes into 243? 81, but we're going to use negative 81 because we have something to do with negatives now. 81 times 3. K can't do anything with that. M can't do anything with that. N squared is already even, so we'll leave that. Square root of negative 81 is 9i. The square root of nothing, n squared is n. So this is 9in square roots of 3km. I've been checking my work. All right, almost done. This is going to be equal to the square root of negative 19x y squared y all over the square root of 100. All right. I can't do anything with the square root of 19, but negative, I can do that. That's I. And this is y. And this is 10. So it's I, y, square roots of 9xy over 10. 19. All right, almost done. These are all perfect squares. Yay! The square root of negative 400 is not negative 20, it's 20i. Square root of x squared is x, square root of the y, the 4th is y squared, and this becomes z to the 4th. I can't tell you how many kids are going to try to take the square root of a negative number and think it's negative. It is not negative. It is I. So this is 140i x y squared z to the 4th. We're on the last page, kids. Oh my God, this drawing is so cool. It is. Just keep telling yourself that. Powers of I. Powers of I. See, you now can understand some jokes. Like, if I told the joke, you would know that means I love you. Oh my gosh. See? Now you know that that means I. And now you can tell cool jokes like this. Isn't that cool? I thought it was cool. I don't care. Anyway, powers of I. This should say I to the 1 right here. Powers of I. I to the 1 is equal to the square root of negative 1. Well, then wouldn't I squared be equal to the square root of negative 1 squared? And didn't we just talk about earlier that a square and a square root cancel each other? So I squared is equal to negative 1. Huge, huge, huge. That's the big one that comes up all the time. Ding, 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 ding. Remember that one. So wouldn't I cubed just be I squared times I? And didn't we just decide that I squared was negative 1? So this is negative 1 times I. Well, this is just equal to negative I. Yep. And then isn't I to the 4th really just I squared times I squared? And we decided that I squared was negative 1. So this is really negative 1 times negative 1. And isn't that just 1? Yep. So let me get rid of my work, even my cool little gig there. And let me try to get you to remember how to solve these. This is the big one. So you have to really remember that I is equal to the square root of negative 1. Well, we don't really need that for this case. I to the 1 is just I. So this is really just equal to I. I don't know why I put square root of negative 1 there, actually. I. So if 1, and then if you draw your circle out, you'll notice on the opposite side, it's just negative I. And then we said I squared was negative 1, and if you notice on that side, it's just positive 1. So I to the first is really just I. On the I cubed, then, is just negative I. I squared is negative 1. And again, I can't tell you, I cannot stress this enough. You better have this one memorized. This one is huge. So let's see how we're going to deal with that. This, if I multiply, don't forget, if we multiply, we add the exponents. This becomes I to the 7th. Okay. That's 1, 2, 3, 4, 5, 6, 7. Oh, that's negative I. I to the 5th. One, 2, 3, 4, 5. Oh, that's just I. Why can I not get rid of whatever that is? Oh, there we go. This is just I. I to the 15th. Now, that's starting to get annoying. I don't want to count 15 times. But notice every time I get over here to 4, it's back at 1. So 4, 8, 12. This would be I to the 12th would be right here. 13, 14, 15. Negative I. Got a couple left. Now, when we have an exponent raised to the exponents, we multiply those. So that's I to the 8th. Well, I to the 8th is I to the 4th, and I to the 4th. That's really just 1 times 1, so that's just 1. This would be I to the 21st. Okay, so let's see. This one right here would be 4, 8, 12, 16, 20. So I to the 20th, remember, notice it's just a multiple of 4. I to the 20th is here, so 21st is just there, so that's I. And then this is just I to the 4th, which is just 1. Now the good news is your calculator pretty much does it all for you. So that's one of the reasons I kind of like this TI Inspire. I could, if I wanted to, bring my TI Inspire over. Let me see if I can get this shrunken up a little bit. Here, I'll do this. So what we're going to do is we're going to just check these out. So I'm just going to write it. Let me just get rid of this menu. So if I go down here in this pi button, you see down here in this pi button, I click on that, and there's I. So I should have put parentheses. So parentheses, that was I to the what, 5th? Parentheses, I squared. And that is negative I. Let's do the one that's right here on the bottom so we can do them at 2 at a time. So parentheses, I raised to the 4th squared. That's I to the 8th is 1. So actually our calculator is kind of nice. It does a lot of this stuff for us. Let me just do one more. Let's do, well, whatever. We'll do this one, I squared, I cubed. I, and then I to the 21st. And I can just, you know, a lot of times typing all that crap's in easier. I would rather just do I to the 21st. But lo and behold, it does all the work for you. But I am going to expect that you know the I circle and that you can do them by hand because I will take the calculator away from you. Although you can use it, you still have to understand some of the principles behind the I circle and what I actually means. All right, kids, that's it. That's the end of day, what are we on? Day 3? That was day 3. Oh my God, it's awesome.